Okay, first section in chapter 8 is 8.1, and we are adding and subtracting polynomials. Well, first we have to understand all about polynomials. So, basics. A polynomial is a monomial, or the sum of monomials, in each is called a term, okay? A polynomial cannot have, this is the part that's important, it cannot have negative exponents, so x to the negative third. It cannot have variables in a denominator. We've never been allowed to have those. You cannot have variables as powers. So you can't have like a to the x power. Not allowed. And you cannot have the radical of something. You can't like have the square root of x. Okay, then it's not a polynomial. It's a radical function, and they look like completely different pictures. Okay, now a monomial, which is what was in this stated in the definition, means it's one term, right? Like 5x. That's a monomial. Binomial means two terms. Now the terms are separated by like addition or subtraction. So 2x plus 5. That's binomial. Trinomial, think tricycle, 3 wheels, 3 terms. Okay? Again, separated by addition or subtraction. After 3 terms, we just call them polynomials. Okay. A degree of a monomial. So only a monomial. Okay, if you're just looking at one term, you look at the sum of its variables, all of its variables, okay? So if you had this right here, 2xy. So x is to the first power, y is to the first power. Though you can't see them, x and y are to the first power. So 1 plus 1 is 2. So the degree of this term right here would be 2 because of the sum of the powers. This guy right here, 15x, you only look at the variables. The sum of the powers is 1. So the degree of this thing would only be 1. Now, the degree of a polynomial, you look at the whole thing in a big row, which there's some right here, we'll practice it. It's the greatest degree out of all the terms. So you have to look at all of them and say which one has the biggest numbers in each term. Okay, so you don't add them all together, you look at each term separately, go which one's the biggest, and we'll practice it right over here. Okay, now, when we look at degrees, they also have names, okay? So we don't say degree 1, we say, if its degree is 1, it's linear, okay? So if degree is 0, right, that means we have no variable, right, like 5. That's a constant number. We've already known that. Right? If the degree is 1, right, like 15x, we call that a linear degree. So we call it a linear monomial because this only has one term. Okay, next one, if the degree is 2, right, like the thing we did, 2xy, then it's a quadratic, so you call that a quadratic monomial. These are all monomials because I didn't put any addition or subtraction in them. Next, if the degree is 3, like the example right there, then we call it a cubic monomial. Again, 3 right there. We don't care about the whole number. We're looking right there. 4 is called quartic. I always think 4 quarts in a gallon. So again, look, 2 and 2, you add those together. That's where you get 4 from. So 4 quarts. So this is a quartic monomial. And then 5 is quintic. So x to the 5th, that's where that 5 comes from. And I always remember because I used to watch a lot of those movies. It's like people say that like when women have so many babies at a time. So a woman, when like you know like twins and stuff like that. So a woman that has 5 babies at one time they're called quints. That's the only reason I remember them. Okay. And then 6 or more, we just call it that degree. So if you had a 9th degree polynomial, you'd literally say 9th degree because apparently they got tired of coming up with names, okay? So you just say 6th degree monomial, 7th degree monomial, okay? So over here, determine if each polynomial, if so, determine if each is a polynomial. If so, find the degree and determine the name. So you look at it first and go. Does it have any of the bad things we didn't want? No, negative exponents, variables in a denominator, powers, variable powers, and square roots. Does it have anything it shouldn't have? No, it does not. Okay. So if so, find the degree and then name it. So the degree, you look at one term at a time. Variables here, that power is 1. Does it have any variables here? Nope. to the power is 0, so the greatest number is 1. And with a pencil, I just go over it. If it helps, I just go over and go, okay, this one's 1, this one's 0, because eventually if they get too long, you get distracted or there's too much going on. So then you go, okay, the degree is 1, so over here, that's linear, and then how many terms is it? 2. So then I would call that a linear binomial. It's hard to write through the camera, okay? Now this next one, negative 6.5. Is that a polynomial? Well, does it have any things we're not allowed to have? Negative exponents, x is the denominator or the radical or anything? No. Okay, so it's a polynomial. Degree. It has no variables. That means its degree is 0. If its degree is 0, what's it called? A constant. How many terms is it? It's only one term. So you call it a constant monomial. Okay? Next one, is this a polynomial? Look at it. The answer is no, and the reason for that is right there, a to the negative third. Remember, we cannot have negative exponents. So since it is not a polynomial, you don't answer the rest of the questions. You just stop. This should be squared. Okay. Oh, that's ugly. I'm going to fix that. Can't do the camera. Okay. So now we look at this one. 6x to the third plus 4x squared plus x plus 3. So is it a polynomial? Does it have anything we don't want? Negative exponents, variables in the power, square roots, any of that. Drop in the phone. Okay. Okay, it is a polynomial. Then look at the degree. What's the biggest degree we have? It's 3. What's the word we use for 3? Cubic. So I'm going to write the word cubic. And then how many terms does it have? 4 terms. So we didn't have something for 4 terms. So if we don't have a word for 4 terms, what do we call it? We call it polynomial. Okay, now the last one. 10x to the fourth minus 8x to the a. Is it a polynomial? Why is it not a polynomial? That guy right there, right? A tells us no, okay? So that's part of your homework. Now the next part, standard form of a polynomial. So, just like this guy, number 4 is a great example, okay? It has to have the terms in order from greatest to least degree. So that one already is in greatest to least degree. So third power, second power, first power, no x's. So you put them in greatest to least order, not by the whole numbers, by the degree, and then leading coefficient. The leading coefficient is the number that's attached to whichever one determines the degree name. So the number 4 up here, cubic is the word. So 3 is the thing that says it's degree. So what's the whole number attached to that? 6. So that would be your leading coefficient. Okay? So we're going to practice that right here. So look at this one. 3x squared plus 4x to the 5th minus 7x. So it says write each polynomial in standard form and then identify the leading coefficient. So you already know it is a polynomial. You just have to decide what's the degree, so we know which one's the highest one, so we can put it in order, and then what's our leading coefficient. We need to write it in standard form. So which ones are greatest, 2, 5, or 1? And everything in front of it or attached to it goes with it. So 5's first, so that's going to be 4x to the 5th. Next highest one is positive 3x squared, and then negative 7x. So then your leading coefficient is 4. So I would write leading coefficient, I always abbreviate it as 4. Okay, next one. This one just has y's. It means the same thing. What's the greatest power? Okay, it says negative 2y to the 4th, and then negative 6y to the 3rd, plus 5y minus 9. What's your leading coefficient? negative 2. Negatives go with it. This one, that's supposed to be an x. What's the highest degree? 4x to the 4th. Negative 2x squared minus 3x plus 8. What's your leading coefficient? Is 4. Last one. What is your highest degree? Next highest. Keep going down. Leading coefficient. If you want to look at each of these, we could also try to name them. So that's my leading coefficient. What's my degree? It's 5. So if your degree is 5, look at your chart, because you can pause and copy these as you go. How would we name this based on the degree and the number of terms? So 5 means quintic, number of terms 3. So this is a quintic trinomial. This one, degree is 4. That means quartic, and 1, 2, 3, 4. 4 terms means polynomial. So quartic polynomial. Again, pause these, try these on your own, and then listen and see if you get them right. Next one, also 4. So we should know that the degree is quartic, and then 1, 2, 3, 4. Oh, again, it's polynomial. And then this one, 6th degree. So we literally write 6th degree, because remember 6 or more just means we write 6th. Then 1, 2, 3, 4, 5. 5 terms means polynomial again. So 6th degree polynomial. Okay. The last section of your homework is actually the name of the topic. Ignore my handwriting. Find the sum or the difference, okay? So you want to combine your like terms. You can only add things together if they are exactly the same with the variables. So the first two have addition. Those are the easiest ones. So 2x squared plus 5x minus 7 added to 3 minus 4x squared plus 6x. Okay, so when you have two sets of parentheses, but they're added in the middle, do you really need the sets of parentheses? No. So when the parentheses are gone, you go, which ones are the same? So I just circle them. So this has an x squared on it. So anything else in this whole thing have an x squared. And I'm going to circle the whole thing, including the sign with it. And then I would combine those like terms. Like over here, because that's where my room is, I would combine them. So 2x squared minus 4x squared is negative 2x squared. Because you leave the x squared alone and only combine the numbers. Because when you add or subtract numbers, you leave the variables alone. So we come over here, and then this next one, and then I'm going to squiggly line this. Squiggly line on just anything with just an x. And I come over here, keep looking for anything with just an x. Squiggly line that. So 5x's positive and 6x's both positive. So 5x's plus 6x's is really 11x's. And I come back over here. This is a constant, right? No number left over. I can box it if I want. Also, it's the only thing left. Is there any constants left? Yep. And since there's no sign in front of this, it's positive. So negative 7 and positive 3. Add them together, you get negative 4. And how you know you're done is you look at your thing. Can you combine any of these? Also, is this in standard form? And if I wanted to, I could ask you, what's the leading coefficient? What's the degree? How would you name it? And name it means based on the degree and based on the terms. Okay. Now you try the next one. I messed this up. So you just look at all this. There's plus signs between all of these, which means you just really add them together. So I always look for the greatest degree I see in the first half. So y to the third. 1 y to the third. So you see any other y to the thirds. If you do, I'm together. So 1 y to the third and 2 y to the thirds is really 3 y to the thirds. Then I think over here you see y squareds. Right here. I don't see them anywhere else. Right? So just that one. So since there's only that one, you just bring it down. And you keep going. Y to the first. Okay, I have that y to the first. That y to the first. So 3y to the first and minus 4y to the first. So 3 minus 4 is minus y. I put minus 1y. Oh, I switch my y's every time. And then last, I have constants. Negative 5 and positive 8. So 5, negative 5 plus 8, or 8 minus 5 is 3. Again, check your degrees. Are they in order? And then, now these ones, these are all subtraction. This one I wrote the number wrong, so it's just be minus parentheses negative 2x to the third plus x squared plus 2. Okay, now for these ones, since subtraction is in the middle, before you can combine like terms, you have to take this negative and distribute it to everything behind it. So you will change all the signs behind that negative, distribute. Then you can add all your like terms. So same process, but you have to add a first step. Okay? I'll do one of them with you, okay? So, this one. 3 is going to turn into, actually let's do 5 because it's the one with all the space, okay? So this one, this part stays the same. I'm going to do it up here so I can see without looking at the camera. So I bring the first one down because I didn't do anything to it. Second one, distribute the negative. So that turns into plus 2x to the third minus x squared plus 2. Now I combine our like terms. To the third, 4x to the third, 2x to the third. Well, that's 6x to the third squared. Negative 3x squared. Negative x squared, well that's negative 4x squared. And then we got just a 6x, only one of them. And then negative 4 and positive 2. Negative 4 here, positive 2, add them together, you get negative 2. Check these, none of my powers are the same. That's my final answer. It's in standard form, greatest to least. Look, my leading coefficient, my degree, number of terms.